So here we go. So here is the review session. This is going to go over material from last week, and I'll do a quick presentation at the start and then open the floor for questions. If you want to chime in with chat, go ahead. You can also, if you find a good moment to say something while I'm pausing, go ahead. This is not a formal lecture. This is meant to be kind of, hey, let's go over last week's material in a bit more of an informal setting. So last week, we had one lecture that is not going to be on the exam at all, because if you remember, lecture one was just me going over how the class was going to work and talking about my own experience in Antarctica. Then lecture two, we got to geography, and that material will be on the exam. So we talked about how I essentially started the class off with the extremes of Antarctica. Antarctica is the coldest continent because it is isolated from warm ocean currents and because of its latitude. Because it is so far from the equator, it gets very spread out sunlight as opposed to, say, the equator, which gets full-on sunlight almost all year round. And then the tilt of Earth's axis also puts it in complete darkness for a good chunk of the year. It's the highest continent because the glaciers are so high and they cover up all of the mountains and valleys and kind of even everything out. And remember that it's only the highest continent on average because of this. The ice averages everything out. If you were going to go by actual highest points, Asia would be the highest continent because it has Mount Everest. The highest individual point in Antarctica is a little mountain called Vinson Massif, which is nowhere near as tall as Mount Everest. But Antarctica is mostly covered just in the east and west Antarctic ice sheets, which even things out quite a bit. It is the windiest continent, to a large extent because the Southern Ocean is to a large extent because you just have winds encircling the Southern Ocean all the time, and also because Antarctica is a high pressure zone where you have air falling from the atmosphere and landing at the South Pole. And you then get the intense katabatic winds, the pressure winds going out towards the coast. Something I will talk about in the next lecture, but last week's lecture, I talked about how it's the driest continent. It's a big desert, even though people don't realize that. And all of these factors contributed to it also being the least populous continent. It is so cold, so windy, and so dry that, and also, for that matter, so isolated from the rest of the world that it has never had an indigenous population, and the only people there now are scientists. There's no other stations of any kind. And in terms of some important terms to know from the lecture, and one thing is that I'm kind of going to make these review session slides a little more bare bones to just put the terms on here. But I talked about latitude versus longitude. The two lines that you together need to use to define where anything is on the Earth. But you have lines of latitude that run east to west, but they tell you distance north to south. And this is something that I notice people get confused on quite a bit because they think that they hear the term they run east to west and they think that that should measure distance east to west. But if you think about it, they're running east to west because the equator we'll start with. The equator goes all around the world. The equator goes from you could hypothetically stand on the equator, and if you could walk on water, you could walk from Brazil to Angola to I'm trying to remember what other countries are on the equator, but you could walk around the world on the equator. What you're doing, you'd be moving east to west, but the key thing was that your position north-south would not change at all. You would be the same distance from the equator, aka zero, because you'd be walking on the equator the entire time. And the same would be true with 30 degrees north. If you walked on the 30 degrees line of latitude, you would be walking east or west, but you would be staying the exact same distance north the entire time. You would be 30 degrees north that whole time. Lines of latitude run laterally. If you've ever heard of like lateral thinking puzzles, I use that mnemonic to help me sometimes. And lines of longitude, I try to remember that they've been a problem for map makers for a long time, forever essentially. That's how I remember that longitude are the problematic ones. And lines of longitude run north-south, but if you're, say, standing on the prime meridian or the Greenwich meridian, but basically the line of longitude that map makers chose as the arbitrary 0 point, you're going to, if you were to walk up and down it, you could walk from the North Pole to the South Pole. Lines of longitude actually run all the way from the North Pole to the South Pole because there's no east or west pole or anything. They all converge at the North and South Pole. But you would be staying 0 degrees east the entire time if you were to walk on the prime meridian from the North Pole to the South Pole. Each line represents a single number, and that means you're staying for a line of latitude either at that same distance north or south the whole time you're on that line, or for a line of longitude, you're staying that same distance east or west of the prime meridian. We talked a little bit about map projections and how the fact that the lines of longitude all converge at the poles make accurate map making at the poles difficult. So they invented something called a polar projection to reduce distortion rate at the poles. We talked about a specific type of map called a topographic map, which will show up in lab this week. And remember that topographic maps show height. They use lines to show mountains and valleys and put them in 2D form. The lines each represent distinct elevations, and between two contour lines, you have a set change in elevation, which is going to be established somewhere on the map. For the maps that you are looking at this week for the lab, you are going to want to look in the legend. You're going to look in the part of the map that has units and tells you what different terms on the map mean. That will be where they establish this is the contour line for this map, so that when you see, say, one line that has the number 200, you can ascertain that the next contour line to it would be 400 feet. That means and that the line after that would be 600 feet, etc. In terms of specific Antarctic features, you want to know east versus west Antarctica and which is bigger and which has a bigger ice sheet. The East Antarctic ice sheet is much bigger. East Antarctica, as we'll learn about in the geology unit, is it's what's called a craton. It's a massive land that's been more or less in one piece and stable for billions of years, more or less since Earth formed. But the West Antarctica is the smaller part with the peninsula, and its ice sheet is much less stable because it's much more in contact with the ocean. They're divided by the Transantarctic Mountains, which extend into the peninsula. We learned about the Antarctic Circle. The Antarctic Circle is defined as it's the line of latitude south of which you get at least 1 day of complete darkness and 1 day of complete 24-hour daylight at least once a year. We learned about the Antarctic convergence, the front where you have a distinct temperature drop, and that's kind of what's often that the Antarctic convergence in the ocean is often used to define Antarctica, because not all of Antarctica is actually south of the Antarctic Circle, but all of Antarctica is south of the Antarctic convergence, as are the various subantarctic islands, which is a term I want you to know. I don't need you to memorize all of the different islands. Like, I'm not going to show you a map and tell you, are these the Falkland Islands, or are these the Crozet Islands? Because that's not really helpful for this class. But I want you to know their significance as penguin colonies, as wildlife in particular, as their significance for wildlife in particular, and they will come up again when I talk about penguins, and as well as when we get to the history of Antarctica and talk about the history of sealing and whaling. And then there's the Southern Ocean, how it's just kind of defined as all the waters around Antarctica, even though you'll have technically it's like part of the Indian Ocean extends. It's like technically Antarctica is surrounded by the Pacific, the Indian, and the Atlantic Ocean, but because of the Antarctic circumpolar current, the water around Antarctica is pretty isolated and functions as its own ocean in a lot of ways. One thing I do want you to know is I'd like you to know where the main US bases are, because there's only 3 of them. There's McMurdo Base on the coast, the largest one. There's Amundsen Scott Base at the South Pole, and then there's Palmer Station on the peninsula, which is largely the resupply station. But I have more info on all of those in the slides from last week, so take a look at those and just be familiar with the US bases and roughly where they are. I mean, it's pretty distinct. Peninsula is the Palmer Peninsula. You can use some alliteration there. And Amundsen Scott is named after two people who made the original race to the South Pole. If you're wondering, if you're trying to remember which one of them is the South Pole base, it's the one named after two people, because those were the two people who tried to race to the South Pole. Amundsen got there first, and he survived. Got there second, and didn't make it on the way back. But they named after both, kind of out of respect for them and for that whole incident. So a lot of last week's material is good to go over throughout the course as we get into climate this week. If you're finding yourself confused with latitude and longitude, I don't talk about longitude as much in this week's lecture because longitude has to do with time more than anything. Latitude actually affects climate more because different latitudes get different intensities of sunlight, and that drives circulation overall. But it'll also come up again with the history of Antarctica and with geology. So are there any questions? Before I talk a little bit about this week's lab material, does anybody have specific questions about last week's material that they're okay going into the recording? And I only mentioned, oh, go on.
Oh, sorry. I was just going to say, could you go over the, what exactly is the Antarctic Circle again? I was kind of a little confused about that part in the lecture.
Yeah, so the, so remember that how the intensity of the sun is going to depend on how north or south of the equator you are. The equator gets the most intense sunlight. So the Antarctic Circle is a line of latitude. If you go south of the Antarctic Circle, any point south of the Antarctic Circle, there will be at least one day where you have 24 hours of continuous sunlight, meaning that the sun never sets for 24 hours. And at some other point in that year, there will be 24 hours in which you never see the sun. So it is basic. So basically, anything south of the Antarctic Circle, there will be at least one day of complete darkness. And the same is true of the Arctic Circle. North of the Arctic Circle, you will have at least one day of complete darkness per year. So it's not going to be like the same amount of darkness. Like if you're right south of the Antarctic Circle, you're going to have more days of daylight than you are if you're at the South Pole. But it basically means, if you look at the diagrams of Earth on its axis, you'll see in the depth of winter, there's a part that's kind of always in shadow. That's not quite the Antarctic Circle, but it's a line defined like that. It's the part of the Earth that's going to be in shadow in winter. Does that make sense? And the Antarctic convergence is more of an oceanography concept, as opposed to one simply defined by latitude. There are different ways to define what is the Antarctic.
I see. Thank you. That makes sense. Thank you.
Yep. Other questions? Okay, I'm going to move on to this week's lab, which draws on lecture material from last week. So first off, there is an excellent presentation that the TAs put in the folder that says Lab 1, files needed. If you have not already looked at that, take a look at it. They go through a couple of examples similar to the questions you're expected to answer for the lab. And I would suggest looking at that presentation maybe with either last week's lectures or your notes from last week's lectures in hand, just to see if terms you recognize start coming up, or if there's terms that I went over last week that the TAs then bring up and you realize you're struggling with. Because Tuesday, I'm recording this Monday, Tuesday is when the TA's office hour sections start. And honestly, even if you find the material relatively straightforward, if you haven't met with the TAs, I'd suggest dropping by at least just to say hi and establish a rapport with them maybe. But a couple things I want to mention are that I mentioned the map legend before, and I've noticed that with this lab in the past, there's a lot of mistakes people make where they'll instantly go to like the submission quiz itself, which is they'll go to the actual assignment they need to turn in, and they'll be like, wait, where do I find this? And you might be able to avert some of those questions if you just, before you do anything, when you get to the maps that you're supposed to look at for the lab, just take a look at the maps, try to see if you understand what's in the legend, what it says. You don't have to know every single term, but you want to see where is where, like what's the contour interval, what are the units being used in this map, what is the scale? The scale is going to tell you, so what a scale does is a map says that if you have an inch on a map, if the scale of the map says 1:20,000, that means that 1 inch on the map corresponds to 20,000 inches in real life. The same is true of a centimeter. 1 centimeter on the map is going to be equal to 70,000 centimeters in real life. And each map is going to have a different scale that's probably going to be in the legend. It's also going to be worthwhile to take a look at the edges of the map and look at the latitude and longitude markings. Something that's a little tricky for some people is that a map is going to usually cover a pretty small area. So you might have, they're going to put a latitude marking at the top of the map for the most northerly point and another latitude marking at the bottom of the map for the most southerly point. And you might notice, I mentioned last week in lecture that you can divide degrees into minutes and seconds. So you might see a measurement that says 30 degrees north and then 45 prime for 45 minutes, aka 3/4 of a degree, and then like 20 apostrophe for 20 seconds, aka 1/3 of a minute. You might sometimes just see a minute and a second listing by themselves. And it's helpful to look over the map and see, okay, what latitude is this? Because sometimes if it's covering a small area, like if it's a map of Santa Barbara, they'll be like, okay, we're assuming that it's 31 degrees, and they'll have that on the map somewhere. And then on the actual image of the map itself, the lines of latitude they put on the grid will be like 20 minutes and 40 minutes or 15 minutes and 30 minutes and 45 minutes. And you have to look elsewhere to be like, okay, is this 41 degrees in 15 minutes or 42 degrees in 15 minutes? But I've found from my experience dealing with maps and topographic maps is that the more time I spend looking at them and trying to see what's actually on the map before I answer questions, the easier a time I end up having when it's time to be like, where is La Cumbre Peak? Give me a latitude and longitude marking. Other thing to remember, if you have not worked with maps much before, is latitude comes first, longitude comes second, and you need both to specify a point. You're basically intersecting them to get a point, because a single line of latitude just gives you 30 degrees anywhere on Earth. A single line of longitude likewise would give you just 60 degrees anywhere on Earth. You need the intersection of those two lines. Are there any specific concerns or questions people have about the lab? I don't know if anyone has had the chance to look at the TA's materials. I saw quite a few people have actually at least taken an attempt at the lab so far.
I had a question
Yes.
about the lab. One of the questions about like finding a point based on the longitude and latitude, like I got to the general area and it was the same one shown on the like slideshow for support by the TAs or whatever that thing. But then it was like kind of between two contour lines, and I just didn't feel confident kind of doing that part.
If you're asked to find an elevation and you're pretty confident that your line of latitude ends up, that the intersection of your latitude and longitude ends up between two contour lines, you can, if it's smack in the middle, you can estimate. So if your contour interval is 200 feet and the point ends up between two lines, let's say that the line that says 300 and the line that says 500, or the line that says 200 and the line that says 400, you can pretty accurately estimate, oh, it's about 300 feet high. Or I would say like put a little squiggly, like I don't know what the term is for that, like a tilde, like, you know how sometimes if you're making an estimate, I think that's fine to put there. I would say just be very sure that you have the right latitude first. Like double check that you're doing the latitude and longitude right first. But if you're between two contour lines, that means you just have an elevation that's somewhere between them. So that's completely reasonable. because hypothetically you could make the same map and make the contour interval smaller, and you would just end up with a map with a much denser set of lines. A lot of map making is really a very arbitrary human thing to some extent. Like you could draw in more lines of latitude or longitude to show smaller divisions of seconds or minutes. You could make the contour lines different to try to show different things. But you don't want the contour interval to be too small, because then you're going to have a bunch of really tiny lines jammed up next to each other, and it's going to be really hard to read or really hard to tell one line from the other. So if your point is between two lines, estimate. Other lab questions? Okay, so I'm going to go ahead and stop the recording, but I'm going to stick around and be able to answer questions about either the lab or this material or the class. And I will be doing another one of these next Wednesday, because there's not going to be a lecture that I'm putting out next Monday, because it's going to be the Martin Luther King holiday. And I will also just have a discussion session when I'm around this coming Wednesday. Right, so I'm going to stop the recording.